I'm sorry, we can't hear you.
Well, there we go.
Sorry, Tom was muted.
Can you hear now?
Yeah, can you hear us?
Yep,
Yes.
we're all set.
Okay, no,
Good.
sorry. At first I thought you were just fiddling, so I didn't realize we were supposed to be paying attention.
So the GTAP model has 1,000 rows and columns, and the GTAP WinDC model has
Right there, 13,000, right?
13,000. So it's a factor of 10 bigger.
So
Right?
just in 2 sentences, just repeat because they were on mute that day.
So, okay, so what we're doing is we're taking a very simple representation of 25% tariff on US steel imports. And what we're going to do is just to do that simulation in the GTAP model. And then we're going to do the same simulation in the WinDC model with state level subregions.
Yeah, perfect. Yeah.
So we move from a model, the size of the model increases by a factor of 10 to 12, so it gets a lot bigger. And so for the purpose of this debugging stage, and the thing we're going to focus on now is this typical way that when you get started with GAMS, you take an existing model and then you want to do some experiments and understand what comes out. It's the first thing to learn to do is to set up a simulation that's interesting. And then you want to think about reporting the model and then comparing the results. So we here are interested in what happens in the GTAP style model versus the GTAP WinDC model. This is not exactly GTAP because it has simplification of final demand. There's a couple of things that are different, but the basic idea is what do we get when we disaggregate the US? My expectation is that the overall effects should not be that different, but let's check and see. So we can see what happens by sector. So, and part of that process now, when you work on reporting, a standard trick in GAMS programming to do that is you do this syntax here that says, so the model name was GTAP. I say gtap.savePoint equals 1. That says every time to solve the model, take the most recent solution and put it into gtap_p.gdx. Put the solution values in there. And then once we have that in a P, then we can do an execute load point that says, go and get all the values to initiate the model from that file.
Please put an asterisk and like just say what it is doing so that
Okay.
when we go back
Yeah.
like a week from today
Okay, instruct
or for people
GAMS
who are not here.
to create a save point
Thank you.
file when after it solves model is solved. The file written here is written to, in this case, to gtap_p.gdx. Okay. Okay. Then, so if the model has already been solved, if there is a save point, then read it. This-
Load up the GDX file, right?
Yeah. This will increase the speed of the procedure of the run. So when you're doing development, a useful trick when developing report code, because then you regenerate the model, but it doesn't take long to do another run. So if I say GAMS gtap_steel, I think it should actually does one replication, and then it does one, so you can see it's right at the solution.
Mhm.
And then then if I go to GTAP WinDC, I think get this guy to go. So GTAP1DC steel is here. And I've done the same thing here. So the same comment will apply. The final thing I want to do is just to save myself some time is I'm going to go to my, I'm going to go to GTAP1DC. I'm not going to require that the model generate it. Let's just go down here and let's just say exit. So this is that way we don't even do that first run. So if I get GAMS, GTAP, NDC steel, it should just do one and it should be right at the it should skip the first solve and it should be right at the solution unless I didn't do the solution. Let's just see how that goes. It's a big model, right? It's 11,000 equations.
Let's just see how it goes.
Here we go. So it's right at the solution. It takes some time for it to read the data, but basically it runs fast. So now what we want to, oh, and yeah, probably, actually, I don't even like to have it. So that's save equals GTAP1DC. So again, this is another trick in GAMS. I don't even like to wait this. I don't want to wait this long. So now I do it with a save. And then I can do a restart from that point and it just continues right from where I left off. It doesn't have to rerun again. It's just this one of these things. So, but that guy's, it's already at the solution. So now let's go in here and look at what our model should look like. Let's look at, so, and I'm going to just do this from scratch, even though I could dig around in my drive and find other reporting code, but let's just do it from scratch so you can see what we're generating, right? So this is WinDC steel. I'm going to say label report. I'm going to say go to report. Okay, so I'm going to say here, I'm going to say parameter pivot data. This is a summary. This is a pivot report. And let's think of what we want to do. I'm going to set format could be percent dollars or dollars diff. We can also do some annex. So let's first say what happens to output. So we're going to say pivot data of it's going to be Y GRS, right? And that's going to be the format be percentage change, and that's going to be such that Y underscore of GRS, because I have a logic only once, is equal to 100 times Y dot L of GRS minus 1. So that's the percentage change.
I see.
Right? And if I look at dollar difference, and that's going to be this guy times VOM GRS. So that's the dollar change in output, right? At benchmark prices. And then I could say, for example, let's see what else we want to say here is that's the PY, that's going to be X. Let's look at absorption. Well, let's look at imports as well. So that's production, and let's look at imports. So it's going to be.
So that so then the dollar difference, the -1 at the end.
If the value of the value of Y dot L is 1 at the benchmark, subtract off 1, that's the change, and then you multiply times the value, so you get a sense about which ones. And this will be Y, and this will be M, and this is going to be G, and then this will be I, R, and then we'll put in an XX there just to indicate that it's only 2-dimensional, so we hold like this, and that's going to be M dot L
And that's because you don't have import by state. Is that right?
Yeah, import is only by country, that's right.
Yeah.
So that's M underscore of IR. And that's going to be M dot L, because I'm curious about the difference between the two. We can also look at the, and so this is going to be, and that's going to be dollar difference. Again, this is the same thing. This is going to be M dot L of VIM of I comma R. So that's production and imports. That looks fine. Now let's focus on what happens to a household. And that's going to be, we can look at welfare or consumption. So this is going to be C
Mhm.
of, and that's going to be H. I'm going to stick to the same sequence. Got to keep them the same thing. There'll be household, region, and then subregion. I'm mixing those around so that I have the same. That's going to be subregion. And that's going to be such that RH of RSH. And that's going to be C dot L of RSH minus 1. That's the same thing as I look at, and that's going to be C0 of RSH times. So it's nothing complicated. This is just looking at a few things. And also prices are useful to look at as well. So let's look at PC and look at factor prices as well. So I want to look at, no, let's look at PF, which will be factor prices. PF of FRS is going to be equal to such that, let's just, I think we'll keep them all, we'll just keep the same FRS. And there's going to be PF dot L of FRS divided by P num of RS. So we're going to have a numeraire price index that we'll construct. We'll just produce a consumer price index at that point. And this guy, and then we want to say, what's the dollar value of that? Well, that's going to be the change in price times the sum over H of EVOMH of FRSH. So that tells me then, right?
What is Evo MH?
What's it? EVOM is the endowment
Oh, okay.
Yeah.
now.
of
Yeah, that-
factor
Okay, I
F.
see.
So that guy, and I have to produce a numeraire price index. So P,
From a semicolon in the penultimate line, yes.
P num of R comma S is going to be equal to sum over H of PC dot L of RSH times C0 of RSH divided by the sum over H of C0 of R comma S to H. So we have a different price index for each household, getting the difference across those guys.
Yeah, now we just run, right?
Yeah, and then we save this guy out. So parameter P num. So now it should be such that if I say GAMS, GTAP, WinDC, field, X equals pivot data. Of course, it never works the first time. Was pivot data? Oh, I didn't do a comma at the end. It's always the semicolon. So I forgot. One error message. Oh, okay. So it's going to be RH. Scott, I should take this away. Divide by 0 at 951. 951. Oh, PNUM. Okay, so that says. And that's the way in GAMS, you have to divide by zero, you say such that means it only does the assignment if that thing's not zero.
Yeah, that's sounded. Okay. Debugging.
953. So I'm looking for the error message. That's PNUM. Okay, so this guy again, I have to say. So it's going to be, this is going to be such that it's PNUM. And that's because the states don't exist in the other regions, so it doesn't know what to do. Display. Let's just say option pivot data. 0, 1. That says put all the 0 means put all the labels on the row, and 1 means 1 entry per row. That's just the way it works. So this guy pivot data. If I do the display, then I can look at the solution. And this is the way in your reporting, you don't want to be rerunning the model and waiting a long time. You want to be able to go boom, 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 boom. And that now we see the percentage changes and all this stuff is all looking pretty good. Now, let me just try one other thing here.
So let's see which state gets most affected.
Yeah,
that?
exactly. That was my question.
Yeah, exactly. So we can look at this, but let's first to double check it. It just occurred to me that I can avoid messing around with the GTAP model entirely. This thing, one of the keystrokes I do causes this thing to come unhidden. I hate it when software makers are looking over your shoulder, your keystrokes, and then they do stuff in response. It's like, I wish I could just turn all that stuff off. It's bad. So WinDC, we have this. This is going to be, that's the WinDC data. Oh, GTAP WinDC. We have WinDC 7 stub. So let's do that. We do this with data set WinDC 7 stub. I'm going to say if not set, yes. And that's the data set. And then I'm going to say here, I'm going to say, do one more thing here. It's going to be data set underscore. I'm just going to use this because that way I can. The thing is, the fact I have the stub data set means I don't have to run a separate model. I can do it all in one model because the stub data set is the same as the GTAP data set. It just has these this rest thing. And then it's going to say execute. Move F GTAP and DC underscore p.gdx ds underscore p.gdx. That way I save it the next time. Still ds equal to WinDC stub. Output equals WinDC stub.lst. GDX equals WinDC stub.gdx. And this why let's look at it, this one, and then we'll be greedy here. It's this guy. Replace CPS. Let's see if we can go that far. Oh. It's the same, I have the wrong name. Let's see, GAMS data, it should be, when do you see 7?
So,
Let's think about how to avoid. Okay, so I'm just running it now just with a stub data set. Just got the one, and that seemed to work pretty fast. Solution found, so let's just say, so this is the CPS. So now we're running these two guys in parallel.
so one's running what, and what's the other one running?
We have two different versions of household data, the SOI and the
Oh,
CPS.
so you're running both, I saw.
I just figured it's mainly just to verify that we're not screwing up. It's not so much, I don't think the differences is that interesting, but it's the fact that I have the two data sets. I might as well, it's free to run the two at the same time, so why not just run them both?
I don't know, that's why you put those two
Yeah.
files names in, I see. Okay,
So what's nice about, once you get a big model running, it's like, you actually do get to use the processor. I like the fact, this guy has a Ryzen 7. It's got the fast processor. It's actually really cheap. It costs like $1,000. The E495 is the plastic case. It's the cheap ThinkPad, but you can get it with these new chips, and the new chips are getting. And Erwin was showing us the thing last week that he got. He has one that's this big, that's like twice as or 3 times faster than this. He got for $1,000, which has 64 gigabytes of memory and 2 terabytes of
yeah.
storage. Right? It's like it's unbelievable what you can do now. So now I've got the point files and I have the stub files. So now I'm going to go back to my run file. It's like you have different ways of doing things. I tend to just like write a batch file because it's easy to remember. If I go to runs.bat, so this has got this guy. And this is going to be EDX. And then it's WinDC 7_stub .gdx. ID is equal to pivot data. Was that what we called? We call that thing pivot data. That's the ID that we want to say. Output is equal to pivot data.gdx. Then we'll say GDX XRW input equals pivot data.gdx. Output is equal to pivot report. XLSX. Par equals pivot. That's the parameter we want to move. It's called pivot data.gx. Range is equal to pivot data bang A2. CDIM is equal to 0. I don't think we have any zeros here. I don't think I have to worry about EPS output, so I think that should be fine. So we're going to say this is going to be merge. Unknown suffix. Oh no, here we go. And stub. Up with the unknown symbol pivot data.
Shouldn't that be when DC?
Well, par is equal to pivot data, not par data. So we merge them all together, we generate a pivot report. Now let's see. I'm not sure. I don't want to raise expectations. I fear that that's like bated breath. We're waiting. I don't know. The results might be crazy, but that's. So this is going to be the data set. Okay, so this is, I'm just looking what I got. This is going to be format. This is value. This is going to be data set, DS, sector, or item, sector, region, subregion. Okay. Insert. And let's just say, first of all, this stuff goes onto there. Data set will be out here. Sector will be right there. Region will be right there. We're interested in the effect on the US. Subregions will go along here. Value will go over here. And then we'll say data design. Move chart. Okay, and then we want to basically here, we want to pick the region we want to pick is the US for the time being.
Yeah.
And then the sector we look at is going to be, let's first look at, wait a minute. Cancel item, let's pick the format. What about percentage? And then sector. What about, I have something that's missing here. Oh, I have to grab the item needs to be, I know which item I want. Consumption. And then I want to say which sector is going to be which households to look at. Oh, where do my households go?
We didn't have the households here in the table. You said sub-regional.
Let's see what I got here. Now, this is where the iteration going back and forth is required. That's by so that's going to be, the sector would be by household. So if I look at household, sector should be, there they are.
Okay.
And then I'm going to say here, it's going to be
Wow, look at DC.
small. So now we see, we get a sense then about
What are we looking at here? Consumption?
DC. We have this in this one case, yeah, we're looking at the welfare effects on, let me just put in a label here that says this is going to be equal. So here's a typical thing I'll do is that, and you want to say equal to C of
So what is H1? That's just one.
that's the lowest income.
Low
household.
income, yeah. Okay, does it
That's
say different
T1.
gradients of income level? Okay.
So I say design at a chart element, chart title above, click here, equal to sheet 1 dash D1. And then we can say, and now let's go back here. Let's look at that. So that's the higher income households. And maybe we're better off. Let me just go back on. Let me just do something different. Let me look. So I'm going to go over down here. I'm going to say,
So it's the same as boundaries than 25% tariff on
Steel.
steel, consumption of that household in DC increases by that much?
Yeah, we got a bug. It's a bug. It's not, okay,
Okay.
it's
I
a
mean,
bug.
but
You know,
like-
the thing is, there's
Yeah.
stuff, we're got to figure out what's wrong here. This is the first time through, so there definitely will be bugs that will show up. But let's go to one data set. Let's go to the data set, which is the CPS data. Or should we go to the SOI data? I don't know which one. So this is,
Basically, DC's a mess.
and let me just, 1 second, let me just go here. There's something, the DC design. Field list, let me get, what I'm gonna do is I'm gonna put the households down here. So now we have it across households. And then that shows, then I think here, subregions, DC looks like it's a bit problematic. So let's look, yeah, I know, we're gonna look at a value filter. Top 10, it's gonna be the bottom 10. Okay, so now we see which ones
Are getting most affected by it.
are most affected by
I
this,
don't
right?
see Pennsylvania.
So Arkansas, Wyoming,
I don't see Ohio either. Interesting.
Iowa, it's interesting. I'm not sure what the mechanism is, but now so the thing is, there are these outliers to worry about at the upper end, understand like what's happening. Oh, let's look here at dollars rather than percentage. So if I look at the format here, I can shift to changes dollars difference. That'll give me a difference. So that's the number of dollars.
Oh, yeah.
So
Yeah,
that's,
some of this could be because it's primary metals as a whole. So for things like Wyoming, it's probably including some precious metals in there.
yeah, there's a variety, there's several things to look at, but and at this stage, it's always a little bit precarious. The first time you run a model,
Yeah.
it's always this process. That's part of the reason I work on trying to get the scripting together to do it, so that I set it up because I know I'm going to go through it again. And I want to do it once and then be able to go back, pop back the command line and say regenerate, and everything goes together. And what's beautiful with the GDX XRW running into the spreadsheet is what I like about the Excel format is we can reload the data and we have to do nothing to the Excel thing other than just say, you just click back in and say, right click, refresh data, and it'll pull all the data in again, and you don't have to do anything. So the data model doesn't change as you format it. But this gets an effect across, this is for the lowest income households.
Yeah, I see that. This makes sense. I mean, yeah.
And then if we go into here, okay, that's by households. We just make one more thing. I'm just curious as to how difficult this would be. Insert, I'm going to say a pivot chart, a pivot table. And let's just go here again. I'm just curious as to how hard this is to do. So here I'm going to go like this, subregion here, region here, sector here, region here, data set here, item here. So then if I go to item being C, the format being percentage change, region would be USA. Data set would be just pick one, say this as the notes CPS.
Yeah.
That's percentage. Remove grand total. Oh, wait, okay, so that gives these guys, and then just a bit of formatting to do here, but I think I can actually get a map here without much trouble. I'm not, it's been a while since I've done that, but I think I can basically go like this. edit, paste special values, no, paste a link. And then I think I can go here, delete this, and then I think I can go in here and I can say, insert map, build map. I don't know, there's a way to do this. It's been a while since I've done it, but basically I think you can get a chloropleth map pretty quickly in Excel. You know, if I took 20 minutes to look stuff up, I could show
It's
you.
all
how to
right,
do-
it's all right.
how to do that.
I see what you're saying you can do. You could basically build a map of the US.
Yeah, you can get the stuff presented pretty well. And to be honest, I'd have to dig in to do more reporting to identify what the factors were, because we can do, when we have the CGE model, we can do, if you do the algebra at the reporting stage, you can say what fraction of this change is due to what. Remember that welfare and well-being depends both on the cost of the goods purchased as well as the value of your endowment. And the value of the endowment depends on what happens to the factor prices, what things you own and what sectors are employed in. So you can diagnose what the channels are through which this operates, right? This is the thing. And I don't know, on the surface, this doesn't look to me, I expect it to be, so this is showing Texas.
I mean, Ohio, Pennsylvania, North Carolina,
Pennsylvania's there.
so they are, this made more sense than the previous one. But,
This is just the.
Then
this
let's-
is just the aggregate dollar difference. Is that
And then
right?
we could also look at dollars, and to be honest, we could look at what happens to factor prices. My problem is that I did not take the time yet to disaggregate the full set of factors. In other words, I'd like to know what happens. You'd like to know what happens to the prices of different types of labor. Well, let's look at sectoral effects. So again, here, this is pivot. I'm going to name this one to be, this one is going to rename this one. This will be C. And this will be the C tape. This will be, rename this guy to be the C table, right? So we have the table and C. I'll get rid of these guys because I don't need those anymore. Oh, no, I need the pivot data.
Yeah.
I'll delete this guy. And then I say, okay, so now if I copy C, I'm going to say copy. And then I say create a copy. And I'm going to call this guy be Y. That's going to be output. And then it's going to be, C will be rename, be Y table. And then this guy, then I can shift to being, oh, wait a minute, I'll go over here. So here I go, item would be Y. And then I'm going to look at, so this is going to be by, what are we doing here? It's going to be, that's by region. So let's go from here and see if the sector goes here. Sort options. Ascending by sum of value, we'll put the biggest losers at the top. And now if I look at, I guess it would be, but this is looking overall output. I guess the thing is probably we're better off. I'm just trying to think about how to best do this. It's going to be sector. Let's look at the bottom value filters, top 20, the bottom 10.
I actually think that the top one was also interesting.
Okay. So this is the biggest losers, right?
And what, so hold on, let me see this.
So we see Indiana, Michigan, Iowa, Wisconsin.
And on the x-axis, what do you have down there, sector?
I guess Oregon and Washington was most like falling and stuff.
Yeah.
Losing.
I mean, you can think up stories that I'm always a little bit reluctant. It's good to guess at what you think is happening, but then you want to get into the math to
Yeah.
figure out what's what. But now let's do a table for winners. So I'll say mover copy. This will be, rename this guy to be winners. This will be the winners table. And then here, guys, going to say filter. So what's going on there? That's really
So
more.
we see the primary metals going up like a lot
Yep.
in Indiana and then Michigan,
So let's
Alabama.
more sort options descending by sum of value. So there's the biggest winners: Indiana,
Yeah.
Michigan, Alabama, Wisconsin, Tennessee, North Carolina. So those are the ones that are there. And the other ones, it's relatively flat. The number of the gainers are that's really concentrated winners in those.
But those are other sectors, right? That's all that is.
Those are all other sectors, right?
Yeah, okay.
I don't know why utilities would gain. Okay,
That's a relatively small amount. If we change, then the thing is, we can also change the data set to see if this is robust or not. That looks, yeah,
Yeah.
qualitatively.
Can you do percentage change? Instead of the,
Yeah, and here we say format to say. So here we have some of these sectors have very small amounts. So I'm not sure exactly how to interpret that. In other words, what's going on over here, there's percentages, that's alt. I'm not sure what that means. I don't know what sector that is. That's probably something that's very, very small. So you have to be a little bit careful about,
when percentage changes, the composition changes.
yeah, I think it's more misleading now because for small sectors, percentage can be very, percentage change
yeah,
can be
that's a good
very
point.
high. That's why I think looking at the values probably a bit better, but I mean, this is just the first
yeah, it's the first pass.
trial, so.
Yeah, I'm not sure I see. But this gives you a feeling for what the procedure is, that you have to basically, you sort of scrape a little bit off, have a look at it, find stuff that's curious, go back through some debugging, figure out where you need to do some additional calculations. And I can show you how to do that. There's ways that you can do disaggregation, and you can check, you can have approximations of what's causing the change in welfare. You can do a decomposition on expenditure and income, and you can check whether or not